All right, so there's one more thing we have to understand about ionic compounds, and that's what are called hydrates. So with hydrates, sometimes ionic compounds have water molecules, right? Water's H2O, as a part of their crystal structure. So the water is not actually bonded to the ionic compounds. However, since the ionic compounds have full-on positive and negative charges, and water has a dipole, there is an attraction there that causes the water to interact with our ionic compounds. And the reason that we have water everywhere is because there's water in our air. So, for example, if you have some copper 2 sulfate, you may have some water molecules that are part of the crystal structure and part of the compound. And later on, we'll learn part of the molecular mass of it. So this is what's known as a hydrate. And so the way that we would name this is copper 2 sulfate pentahydrate. Right, so the penta means 5 and the hydrate means that there's waters, right? So it's always going to be something hydrate, and what the prefix is depending on how many there are. If there's 1, then it's mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hepta, oh my bad, hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. So for example, if you had nickel 2 chloride hexahydrate, right? The nomenclature tells you about the molecule, right? The nickel 2 part tells you that you have a nickel 2 plus ion. The chloride tells you that you have some Cl minuses, and the hexahydrate tells you that you have this kind of fat dot that we use to indicate a hydrate, and 6 water molecules. So the overall chemical formula for this would be Ni and then 2 chlorides to counteract the nickel 2 plus. And then you just draw a fat dot and 6 H2O for the hexahydrate part. So not too bad.